B, E, A, F, and question mark. So there are seven source letters here. If I combine three into 1, I will reduce this by 2. Then I go to 5. Now I have 5. I combine 3 into 1. That'll reduce it by 2. So I have 3. If I have 3 and I combine 2, that'll reduce it to 1. So this was the ideal case. So basically, each time I go from stage to stage, so at each stage, we lose 3 minus 1, which is 2 source letters. In other words, we're taking 3 source letters and combining them into 1. So the number of source letters shrinks by 2. And at the end, we want 1. So in other words, 1 plus the number of iterations, let's call it n, in the basically the number of source letters we want is 1 plus n, where n is the number of iterations in the Huffman procedure, times 2. Because every time we have an iteration of the Huffman procedure, we decrease the number of available source symbols by 1. Or in other words, if we go backwards, each time at each level of the tree, we add 2 source symbols. So if we start with 7, then we'll go to 5, 3, 1, for example. So the rule for ternary, at least, should be this is the cardinality of the source alphabet. So in other words, the cardinality of the source alphabet minus 1 divided by 2 is equal to n, where n is an integer. N is the number of iterations, so n must be an integer. So as long as n is an integer, this works. In other words, cardinality of x minus 1 must be divisible by 2. Which means that cardinality of x must be 5. That's why I started out with the problem, because originally I had 1, 2, 3, 4, 5, 6 source letters, which is even. Okay, let's say we don't have ternary. Where does the 2 come from? So the 2 comes from here. In other words, cardinality of x must be 1 must be divisible by 2. That 2 comes from here. If I have something other than ternary, how does this change?
Difference. Anything minus 1.
Anything minus 1. So instead of this, I have I called my encoding alphabet U. So at each stage, if it's arbitrary, if it's neither binary nor ternary but something else, I lose cardinality of U minus 1 source letters. So at the end, we want 1 plus the number of iterations of Huffman times cardinality of U minus 1. And that has to equal the cardinality of my source symbols. So in other words, the final rule is if x is the source alphabet and U is the encoding alphabet, then what I need is that cardinality of x minus 1 divided by cardinality of u minus 1 equals integer. Or in other words, cardinality of x minus 1 must be divisible by cardinality of u minus 1. If this is not true, what should I do?
And auxiliary.
Add auxiliary variables with probability 0. Or add auxiliary source symbols with probability 0. By adding symbols with probability 0, I'm not really changing the source because something with probability 0 can't happen. But by forcing them to have probability 0, I guarantee that they will be combined at the first stage of the Huffman procedure. Because they will always be at the bottom of the list. Any questions on that? Okay. It's a little early, but I don't really want to start on. The next thing we're going to talk about are Shannon-Fano-Elias codes, which are useful for larger source alphabets. But I don't really feel like starting on that right now, so let's just call it quits right there.